Right, I'll actually start. I'll pull one up from under the bench. I'll actually start with our battery control unit. So our battery control unit, if you like, this is like the master battery management system. So what we do is we hook up the individual energy storage modules. We hook them up to what we call the BCU. There's various inputs and outputs. So one of them daisy chains all of the packs together, and the other one allows multiple inputs and outputs to a vehicle controller. We can control contactors for pre-charge. We can control contactors for switching on thermal management or cooling systems if that's required. So again, very simple EMC proof box, metal housing, standard box, 3 connectors, pretty much plug and play. And we also have an earthing point on this as well. And again, important CE marking that we have there. So again, this gives flexibility. So this can be put, various places on the application, and it increases flexibility. It also means that should there be an issue with the battery control unit, you don't have to return any of the battery packs. All of the electronics, the smart stuff's contained here. This can be returned. We can ship out a spare one, next day delivery, simple plug and play, and then your system could be up and running as well. So again, our previous battery packs had the master controller in each of the modules. We've taken that out and we've separated it. So again, from ease of system integration, serviceability, maintainability, spares policy, going down this route makes it far easier to work with the batteries. So next, hopefully you can see we've got a stack. So we've got the 4.5 module on the top and we've got the 6.8 module on the bottom. The only difference is the width. So the height and the depth is the same. And all of the controls are very common. So the only thing that changes is we have 2 VDA 355 modules in the small one and 3 VDA 355 modules in the bottom. I'll focus on the top one because it makes it easier to look at some of the features. So we've got some Amphenol connectors. So we've got 2 power connectors here, positive and negative. These can be daisy chained, so we can connect these in series and parallel, just by changing the wiring harnesses, and these can be daisy chained together. Obviously you wouldn't do it with 2 different pack sizes, but in theory you just link the positive, negative, and you can daisy chain the packs together. On this side, again, daisy chain concept. So all of the modules can be daisy chained together with an input and an output on these M12 connectors. So they link back, they feed all the information from inside the pack on temperature, voltage and current. So the status within the module all goes back to the BCU, battery control unit, where all of the state of charge, state of health calculations are made. An important feature that we had on this version of our product, rather than that superseded the Gen 4, was this is a simple black box and you don't really know what's going on. It doesn't really make a noise, or it shouldn't make a noise. So we've actually fitted an LED on this, so it's a tricolor. So we can indicate by different flashing scenarios, whether it's green or red or blue, and different combination of flashing and rate of flashing, we can indicate if everything's okay, whether there's an issue with maybe low state of charge, maybe over temperature. So again, you don't really need to hook this up to a laptop to find out what's going on. You can actually look at the LED. That's going to give you a good indication of what's happening. Certainly you can then hook up a laptop to get more detailed information. But if you've got an array of these all in a system, very easy to go in and see if there's a module that's causing an issue. You could isolate that very quickly. So again, serviceability, maintainability, thinking about the user here. So we've got this LED, which is a very useful feature. One of the things that makes us pass the stringent testing on thermal propagation is we've fitted a blowout valve here. So as well as this acting as a pressure relief valve as well, pressure equalization valve, This will activate at a certain pressure so if there is a thermal event happens within the battery pack, the pressure, the temperature builds up, the heat builds up. This will actually blow out at a safe pressure. It's all controlled, so all of the direction, we know which direction it's coming from. So when we work with system integrators or OEMs in integrating our modules into a system, we can advise where to, position these modules. Now, we've actually tested this on the front, we've tested it on the side, and we've tested it on the rear face as well. So we can actually have this on different faces, on 3 different faces, if that helps the integration into the product. So really what we're trying to do is design a system so that if there is an event and there is gases coming out, that these are directed away from the passenger cabin or directed away from where someone is maybe exiting a vehicle. So again, this is a key design criteria when we are working. So our applications engineers work with the end customer to look at the best place that we could mount these. As standard, it comes on the front face, but we have the option to change that around if we need to. So again, being able to pass this test, having this pressure vent in here has been absolutely key to us being able to pass these. Looking at the top face, you maybe look at this and say, wow, what we're doing here, we've got a lot of screw fastenings. And I must admit, when I look at this as well, when the engineer said, yeah, look, we need all these screws. And yeah, it's true. We did the analysis, we done simulations, and then the proof of the pudding was actually in doing the testing. So, we've got a case, which is a welded case on the bottom half, and we have a lid, a one-piece lid, that goes on after the modules and all the rest of the internal assemblies have been connected up. And we have a gasket in here, which is maybe quite hard to see. So we have a gasket in here that, survives the temperature, it survives the pressure. But really, to survive the pressure and to allow the vent to do its job, this is really the number of fastenings that we need on the top to make sure that there's no chances of leaking any gases at any other part other than through the vent. So it looks a lot of fastenings, and I'm sure the production operators have probably some concerns about adding these, but that's what we needed to do to get this pack CE marked and passed. So other features that we've got, so these packs can be mounted really in any orientation. We have a few mounting points, so we have 4 mounting points on the top face that we could securely screw down. These are M8s. We also have on the base, we also have 6 mounting points that you can fasten this and secure it. So we have some mounting feet on the base. These can really be mounted flat, they could be mounted vertical, they could be mounted on their side. We've done all of the validation testing on all of these different orientations. Probably not best to kind of mount it like this, or it'll be a bit complicated. But really it's flexible. So, we could mount this at any angle, any different access, which gives it really good kind of flexibility here. We label it all up. Again, all the labels comply with the regulations, explaining safety, don't remove the covers, etc. These are all specially tooled. What else have we got? Again, everything complies, don't throw it at the bin, etc. All of the labeling complies, and we've got a couple of earthing points here as well. So again, from a flexibility point of view, whether it's better on the right or left hand side, or maybe you need 2, if you're daisy chaining the earthing cable, then we have those couple of earthing points there as well. CE marking and QR code on the side. So, so we've got traceability and we've got our CE marking on the side there of the pack. And again, we have it on the other side so that it's visible in different orientations and installations as well. So, I think I'm just going to quickly look down my notes and see if I've missed it. Yeah, so these are rated to IP66. So again, that gasket, as well as containing any pressure, which I think is, I wrote this down, is somewhere around about 4.5 psi. Is the pressure that the vent operates at. That's really as much as I could say. Inside, we have 2 modules, as I said on this, VDA355. We also have our cell monitoring unit, so we have electronics that measures temperature and voltage of each of the modules, multiple locations within the pack, and as I said, those feed back to the BCU. So this is our Turntide modular packs, 4.5, 6.8 kilowatt hours. I think I've covered most of the features that's on it. How much could you talk about a black box? It doesn't really kind of do that much. But I know from the team of engineers, designers, test engineers, validation people, the guys who read through all the specifications, the amount of work that goes into this is tens of thousands of hours and blood, sweat and tears in trying to make this happen. So, you know, it maybe doesn't look much, but I know all of the effort that's went into making this product over the last couple of years.